Should have started that recording earlier. Should have started that recording earlier. Okay, number 1, we are going to reflect across the y-axis. I'm going to say again, there are 3 methods that I use most frequently. Tissue paper method, which some of you may have seen in junior high. The stick method, which I'm going to do for reflections, and the chart. Okay, you can use any of the 3 methods, but for reflection across the y-axis, I like the stick method. So I highlighted the y-axis, and it's if I am folding this across. So I'm going to make little sticks from the y-axis. From the y-axis to H, from the y-axis to H is that stick, right? 3 units to the right. Now I'm going to fold the stick across the y-axis. And I'm going to call this point right here H prime. Okay, you may have seen letters with little tick marks up on top. That is H prime. Ah, the cabinet, the bookshelf, huh?
This is the one that goes up there.
It does. Thank you. Okay, now I'm going to make another stick for I. Yeah, 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. And there is I prime. Okay, let's do J. So do all your sticks. That's not what I meant. Okay, so what are we going to call this one right here? Yeah, Zoomers. All right, so that one is J prime. Yeah, and then notice I'm folding all my sticks. Fold it across 1, 2, 3, the y-axis, and that one is G prime. Okay, a reflection. So if I put a mirror on the y-axis, it's like GHIJ is looking in the mirror. And when we look in the mirror, we actually see the opposite, right? You know how on your phone, like if you push the little button and take a picture, a selfie backwards, okay. Sometimes the phones are now fixing them. Sometimes you're actually taking a picture of your reflection. Yeah. Okay. But does it make sense now? Yeah. Reflect across the y-axis. Now, it's okay to do it wrong when, like, if you did it ahead of me, okay, and then you watch the video, hey, you actually, okay, so you missed one of the points. Yeah, that's easy to do. Okay. Number 2, reflecting across the x-axis. Okay, let's highlight the x-axis because that's where my mirror is going to go. So let's make the sticks. So make 3 sticks from the x-axis. I'll do the other one later. To the points and reflect them across. So now this stick goes down. This stick goes down 4. Okay, this stick goes 5. So we can see that that point is here. Yeah, stick method. So now label. we have B prime, we have D prime, and C prime. So we reflected it across the x-axis. Not too bad. Okay, we're gonna move on. By the way, at the end, there's always time for questions. So if something didn't make sense, circle it. And when we get to the end, if I say are there any questions, then you can ask. Okay, this one is harder to visualize. Okay, rotation 90 degrees counterclockwise. Now we know a clock time goes this way. So counterclockwise is going to go opposite from what your clock does. Unless everyone has digital clocks and then we don't see the little hand going around. So when you come to my classroom, look at my clock. Okay, counterclockwise. So let's look at the coordinates. A is, okay, Zoomers, go ahead and type in, what are the coordinates of A? Now, I actually don't care if you type in before I say the answer or after, but when I look at the transcript of typing it in, I just want to see that you participated. All right, ding, ding, ding. Over 3, down 1. Okay, yeah, 3, -1. And it's okay. You could say, I don't know, or you could say question mark. Yeah, so over 3, down 1. Okay, super important little piece of information there. Over 3, down 1. Okay, now we're going to look at something. Hopefully. Okay, so new share. This one. Okay, so look at this. I want to rotate it. Oh, am I really glitchy? Yeah, sorry about that. Okay, I want to rotate this. Geometry?
Yes.
Oh, welcome. And we meet every Thursday, 9:30 to 10:30. Right now, you're welcome to stay. I can turn this on. If you feel like, oh, this is too soon, I will send out a link to the video of the session and you can watch on your own.
So she's in right now, but sometimes when we're up and running.
Yes.
Here and she's.
Yeah, people didn't come. A lot of times I have people on Zoom and people in the room. You would not be the only one sitting in the room. Okay, if you have any questions, send me a message. Okay, nice to meet you. Thanks for coming by. Okay, sorry about that. And that's all going to be on the video. Anyway, okay, so watch this. I'm going to rotate this 90 degrees counterclockwise. Okay, so see how it's going to need to be here. Oops. Okay. Okay, so we're going to go back to our paper. This one, sorry. Okay, so we saw in the picture, it's going to need to look something like this. Yeah, so 2 things. You should be able to visualize what it's going to look like. Rotation 90 degrees counterclockwise. Or, and we're going to use the chart. Okay, so hopefully you have this on your paper. If not, it is in the bottom of module 1. And if you stop by my room, I will print out some for you guys. Rotation 90 degrees counterclockwise. Yeah, rotation 90 degrees counterclockwise. XY goes to negative YX. Notice your X and your Y switch places. And the one that goes from the second place to the first place changes signs. Okay, so let's just do, what if this was 2, 5, and we were applying this rule? Yeah, can anyone take a guess? What would this rule do to 2, 5? It would change it. Yeah, Zoomers, can I have a guess? Oh, you are so close. You are so close. Yeah. We're gonna switch order, and the one that comes to the front changes sign. Yeah. Yeah. See how it would, so that says change order and change sign. Okay. What if it was -2, 5? What would that become? Give me a guess. So change order. The one that starts out second and moves to the front is the only one that changes. -5, -2. Still confusing? We getting it a little bit? How about this? 2, -5. What would that one become? Awesome. Yeah, change the order. The Y coordinate moves to the front and changes sign. It's only the original Y that changes sign. Ah, good. Okay. Hey, can you guys type in the answer direct message? And let's give it a few minutes, see if everyone gets a chance to do it. So what would this be? Go ahead and go direct answer so we don't see the correct answers. Testing. Yep, that worked. That's the one. That's me. Oh yeah, direct answer, direct message host. If you do co-host, I won't see it. Well, maybe I'll see it. Ding. Oh, careful. It's a +2. Yeah, that 2 doesn't change. Okay, so we change order. The one that goes to the front changes sign. Yeah, only the Y moving to the front changes sign. Yeah, okay, let's do one more. Let's practice one more. 7, 3. What would that do? The Y moves to the front and changes sign. Ding, ding, ding. The 3 moves to the front, changes sign. Awesome. Okay, I'm getting a lot of good ones. And the 7 moves to the back and does not change sign. Now, do you see how great it is to come to the review session and actually struggle with me and not just, watch me do it? It's the struggle that helps you guys learn a little bit more. Okay, so let's go back here. Oh, I am here. Sorry. That used to be on another page. Okay, so now notice my sketch is going to kind of, pain is muy bad. No, don't feel dumb. Don't feel dumb. Okay, the struggle is good. Struggle is good. Okay, trust me. I don't think you're dumb. I don't think you're bad. Okay, but the struggle is going to help it sink in. Okay, hang in there. Don't give up on me. Okay, so we see that 90 degrees counterclockwise, XY goes to -YX. Now, once we do this, the picture is going to agree with the formula. Yeah, see how this is kind of helping us practice with formulas where the picture agrees with the formula. Okay, So A prime. Yeah? Anyone ready to guess? Anyone feeling confident? Is gonna move to, this is gonna be magical. Once we figure this out, there's gonna be a cool moment here. Anyone feeling bold enough to guess? So 3, -1 goes to, oh, so close. So close. One of those. Oh, no. So close. Change one more sign. Okay. The -1. Oh, wait. Okay. Anyway, the -1 moves to the front and changes sign. The 3 stays. Now, this is the cool part. Once you use the formula, nice bold color. Now let's plug this in. 1, 3, 1, 3. Can you see that that was kind of where I predicted? See how my rotation and my little sketch and my prediction is going to help me verify the formula. Yeah, do we see how those agree? Was that like kind of a magical moment there? Okay, so this is A prime. Okay, this is going to get better, I promise. So B, the coordinates of B are 1, 2, 3, 4, 3. Using our formula, what are the coordinates of B prime going to be? All right, we have a guest coming in. Anyone else? You are correct, by the way. Anyone else have a guess? Anyone else feeling bold? Okay, so I'm going to move the 3 to the front and change the sign and keep the 4. Yeah, so we're going to go -3, +4. Oh, look, kind of where I predicted. Yeah, isn't that nice when you do it 2 different ways and they agree? Okay, so this is B prime. Let's do C. C is 5, -1. Okay, Zoomers. Oh, I almost called you boomers. I'm the boomer. You're the Zoomers. I think you're cheating. Okay. How am I cheating? Okay, anyway, come on, Zoomers. You're the Zoomers. I'm the boomer. Okay, so apply the formula. Y moves to the front, X moves to the back, Y changes sign, X does not. Yeah, can we guess? Yeah, anyone? Oh, one of those signs is wrong. Yeah, David, you got it. David got it. Okay, so we move the Y coordinate to the front, change the sign. The X moves does not change the sign. Yeah, is it getting better? 1, 5, over 1, up 5, over 1, up 5. And it agrees with our prediction. There is our rotation. Okay, now, are you going to be quizzed on this yet? No, I'm actually pre-loading this information. So you're going to think, wait, I didn't even see a video on this. This is actually going to come up in the future. Okay, so this is actually the material. We're going to practice it a little bit, and it's really for week 3, but we're preloading. Okay, so let's do this one. Rotation 90 degrees counterclockwise. Counterclockwise. So can we see that, like, this one's harder to see? Something like that? Yeah, I may be wrong. Okay, so that's my prediction, but we know it's going this way. I'm just not exactly sure about the angle. So let's write the coordinates. We have R is -5, -1, S is -2, 1, and T is -3, -3. Okay, check my, yeah, I am off a little, huh? It was a very rough sketch. Okay. Everyone check me, because sometimes I miss negatives too. -5, -1. -2, +1, -3, -3. Okay, now we know that according to our chart, rotation 90 degrees counterclockwise, XY maps to -YX. Okay, can you guys tell me what R prime is? Hopefully we're getting a little, oh, you're fast. You're like, come on, come on, come on. Correct. Awesome. Anyone else want to guess? Validus. Oh, Mr. Vocabulary. No one's ever told me that on Zoom. Okay. So, no, thank you. You guys are funny. You're making me laugh. Okay. Move the Y to the front, change the sign, move to the X to the back. Do not change the sign. Move the Y to the front, change the sign, move the X to the back. Do not change the sign. Move the Y to the front, change the sign, move the X to the back. Do not change the sign. Okay, let's graph these and see how close my prediction was. So 1, -5. Oh, wow. -1, -2. Three, -3. Okay, my prediction was really bad. So, but it would have helped if I would have gone to that Google page and actually rotated. I would have seen better. In fact, maybe we should do that because my prediction was so bad. Okay, here we go. Now, can you guys see that that rotated 90 degrees? So -1, -2 is S prime. 3, -3 is T prime. And 1, -5 is R prime. Okay. I thank you for telling me I did good-ish. But it did, even though my prediction was really bad, it did help kind of get an idea of where it was going. Okay, so rotations are hard. Am I going to quiz you on rotations this week? No. In a couple weeks? Yeah. Okay, so we're going to have some time for this to sink in. If, yeah, okay, thank you. That's actually very kind. Okay, rotation 180 degrees about the origin. Notice it doesn't say clockwise or counterclockwise. Yeah. So, shall we try stick method? Yeah, let's try stick method. And then we'll look at the chart. Stick number 1 rotates 180 degrees. Yeah. Can you see that? Yeah, well, not, it is more of a rotation. We kind of say mirror for a reflection. Okay, so if you guys don't like this method, we're going to use the chart. So now let's do this one. This stick. Yeah. Now notice the blue one, I went this way. Now this one, I'm actually going to go this way because, so yeah. Okay, so do we like the stick method for this? Let's see. This is T prime. This is U prime. this is W prime, and this is V prime. Now, to be honest, some of my students, some of them see it and some of it don't. Some of them don't. Some of them see it and some of them don't. Okay, but with the chart, in the end, the ones that can't just see it just are comfortable with the chart. Okay, so let's look at this. Rotation 180 degrees, counterclockwise or clockwise, it doesn't matter. So XY becomes negative X, negative Y. Now, notice X and Y do not switch places. All they do is both change signs. Okay, so if I had, according to this one, 2, -5. What would that map to, please? Change both signs. Do not change the order. Anyone feeling bold? Okay, watch this. Change both signs. Do not, there we go. Thank you. Do not change the order. Yeah, think we can do this? Let's do one more example. 5, 7. Okay, rotation 180 degrees clockwise or counterclockwise. Change both signs. Do not change the order. Yeah, is this one easier? Because there's no order change. -5, -7. Whoa. Yeah, this one's better. Okay, so we can see, you might like that better. You might like that better because look at this. What are the coordinates of U? Anyone? Coordinates of U? There's a 3 involved. Yeah. Over 4 up 3. Yeah, over 4 up 3. Okay. Now the mapping for 180 degrees is XY maps to -X, -Y. So what is U prime going to be? All right. -4, -3. -4, -3, right there. Okay, remember when we do coordinates, first we do X, Y, X is horizontal, Y is vertical. That's how we do our coordinates. Okay, if you want to go through and do the mapping on all 4 of those points, the 3 others we didn't do, request it, we'll do it at the end. Let's move on. Okay, so that was the hard part. How many axis of symmetries? Yeah, that's kind of hard to make plural. Anyway, by the way, I used a picture from something else. Okay, an axis of symmetry is a line that I can draw that creates. Okay, we could talk about that. We could talk about that. Okay, let's talk about number 6. See that axis of symmetry? I could flip it, I could twirl it on that axis and it would stay the same, right? The right half maps to the left half. If you want, yeah, you want to sketch this on another sheet of paper. The rest is going to get easier. Okay, notice the right half maps to the left half. Or I could turn it notice if I draw it there and turn your paper, can we see that the right half maps to the left half? Yeah, those are each an axis of symmetry. So how many axes of symmetries do you think we have? We have one going from each side to each side. So for the sides, side to side, we have 3. Yeah, thank you for guessing. There's actually more than that. And then corner to corner, see how that's an axis of symmetry? So corner to corner, we have another 3. Okay, you ready for the shortcut? You don't have to do all this. N is the number of sides of the polygon. What is N? No, you were close. You were close. What is N for this polygon? 6. N is a variable that represents the number of sides. Okay, so N equals 6. How many axes of symmetries do we have? 6, right? 3 side to side, 3 corner to corner. Guess what? Do you have a hypothesis? How can we know how many axes of symmetries there's going to be? It's always the same as the what? N, correct. Okay, if there's 6 sides, there's 6 axes of symmetries. Easy peasy. Okay, let's do this the easy way. How many axes of symmetries do we have? We have 12 sides. So we have 12 axis of symmetries. Yeah? Easy peasy? Okay, I'm going to move on. And so you're going to do number 8 on your own. And you don't need that. Okay, so if you want to see number 8, request it at the end. Number 9. Okay. Oh. You could tell I used other figures to change the problem. Each figure can be rotated onto itself with a rotation. Yeah, if I put my pin here, and rotated my paper, I could rotate it. Yeah, here's my hexagon, very beautifully drawn. If it rotates a certain number of degrees, it sits back and looks exactly like the original. Okay, so rotate it onto itself means thank you. I rotate it, and I'm a really good artist. I rotate it and it looks just like it did before. So the question is, what is the angle of rotation? Okay, angle of rotation. And we're going to kind of sketch it, but then we're also going to do a formula. So angle of rotation. Any ideas? Oh, by the way, this is a regular polygon, 6 equal sides. Yeah, right. 6 equal sides. Okay, awesome. Thank you for that input though. We don't know yet. Okay, what if I drew this? Can you see that that is the angle of rotation right there? Ah, very good. Correct. Yeah, that is the angle. If I rotate it that much, that is how much I need to rotate it so it looks exactly like the original. Okay, so how many degrees all the way around a circle? 360, correct? And how many of these do I have? 6, right? So I'm going to take 360 and divide it by 6 and get 60. Yeah. So I have a variable that I call that number right there. What variable do I call the number of sides? I call the number of sides. Hey, not bad, huh? The number of sides is n. Okay, that's a variable I tend to use for number of sides. So the formula for angle of rotation is 360 divided by n. Notice 360 is a constant, does not change, right? The n is the number of sides each time. Okay, so you're noticing, hey, this is surprisingly easy. Okay, notice the stuff at the top, that's for 3 weeks from now. Okay, I started because it's kind of good to see it ahead of time, but the stuff we're doing right now is not that bad. Okay, that's why we preloaded a little bit of difficult stuff. Okay, let's do this one. The formula is 360 divided by n for the angle of rotation. And what is n in this case? All right, n equals 3 sides. So 360 divided by 3 is 120 degrees. That is the angle of rotation. Okay, 11 and 12 on your own, or stick around and request it at the end. Or sometimes people say, hey, you moved it too fast. Can I just see something? Okay, midpoint formula. Now, if this was one dimensional, and this was 2, and this was 8, how could we get the coordinates of the midpoint? Okay, now these are 2-dimensional, looks like this. But if it was just 1-dimensional, if I go from 2 to 8, how could I find the middle? There's 2 ways, and one involves less calculations. But can you think of a way that would give me the middle? Okay. Yes, exactly. Yes, very good. That's actually the way we're going to do. Notice I could do it the long way. I could go 8 minus 2 is 6, divide that by 2 is 3, add 3 to 2 and I get 5, or subtract 3 from 8 and get 5. Okay, that's the long way that sometimes people suggest. Can everyone see that 5 is in between 2 and 8? Three units on one side, 3 units on the other. The better method is find the average or the mean. 8, well, I'll do it this way. 2 plus 8 divided by 2. 2 plus 8 is 10, divided by 2 is 5. Yeah, that's fine. Okay, so what we're going to do is now we have X's and Y's. So we are going to average the X's and average the Y's. Yeah, we're going to average the X's and we're going to average the Y's. So grab your X's. comma, grab your Y's. And simplify. -10 plus -4 is -14, right? Same sign sum. Okay, -14 divided by 2 is -7. 0 divided by 2. Notice you cannot have a 0 on the bottom of a fraction, but you can on the top. There's your answer. Okay, average the x's, comma, average the y's. Okay, number 14, on your own, or stick around at the end and request it. Number 15, which of these are lines? Lines not according to the everyday language, according to the very specific, correct, very specific geometric definition. Only B. A line by geometric definition has arrows and goes on in both directions. Okay, can anyone tell me what this one is? It's not a line. It's a line. Have you guys seen it yet? I don't know if you've seen it. Segment. It is not a line. It is a line segment. It is only a piece of the line. Notice it has endpoints, not arrows. Ah, ding, ding, ding. This one is, I'll give you a hint. Here's the sun. This starts at the sun, goes on forever. We call this a ray of sunshine, right? This is a ray. Okay. Which of the points are collinear? Oops, that one missed. It looks like only D. Collinear. Line up perfectly. See how B, they're a little bit off. If you put a piece of paper there, you would find that they're off. C, 3 of them are collinear, but they have 4 points, so they're not collinear. Okay. We're gonna do these a little bit quickly. What is the correct name of the ray? You have to start at R. You could say start at R, go through S. Start at R, go through T, but it has to start at R. Yeah, that tells you R is the endpoint in the direction of S, or R is the endpoint in the direction of T. Okay, we're gonna go fast over that one. 18. Okay, this is called the angle addition property. Measure of angle UVW is 1. Okay, thank you for coming. I'll send out the link to the video so you can watch the end. Bye-bye. UVW. So find out which angle UVW is and put 121. Awesome. You're awesome. UVW. Yeah, can we see that that is 121? UVW. Notice V is the vertex. Start at U, draw to V, draw out to W. Okay, now let's do this one. YVW is 88. YVW. Start at Y, draw into V, draw out to W. So this is 121. YVW is 88. So how can I get this missing piece? And David was ahead of me. Okay, so Ella, what do you think? How can I get that missing piece? What am I going to do with the 121 and the 88? We are going to subtract 121, take away 88 is, ooh, thank you for participating, but we're going to subtract. Yeah, because that's not cutting it in half. See how 88 plus that angle gives me a total of 121. Yeah, so we're going to take 121 minus 88. (121 minus 88 is 33. So the measure of angle UVY equals 33 degrees. Okay. 19 is on your own. Yeah. Number 20. Proportional reasoning. One pack of gum has 8 sticks. So, Zoomers, can you tell me how much 2 packs of gum are going to be? Oops, careful. Not 18, right? Yeah, there you go. Oh, whoops. No. Okay. If 1 pack of gum has 8 sticks, 2 packs of gum are going to have 16 sticks. Yeah. So I could either add 8 plus 8 or multiply 8 times 2. Okay. Now, geometry is about justifying and like proving things. Okay. And sometimes we may get an answer, but we may use multiple methods. Okay, so far? So let's see how many methods we can get for this one. Okay, so I need you to tell me the answer and a method that could get me that answer different from any method mentioned before. Right now, we don't have any mentioned before, so any method is good. How many sticks of gum in 4 packs? Okay, could we do that by adding? Yeah, 1, 2, 3, 4. Correct, 32. Okay, so I could get that by adding. How else could I get it? I could multiply, right? 8 times 4 is 32. Now, yes, you are. Does anyone see another connection based on something we did previously? Anyone see another connection? Ooh, subtracting. Okay, that would be good. But I don't think we can get it this time. Okay. How about, can I go from 2 packs to 4 packs? Yeah, if 2 packs are 16, then 4 packs are another 16, so 32. Yeah, so you could go all the way back to the 1, or you can use 2 to get 4. Yeah, pretty crazy. Okay, how about 10? I'm going to erase this. Sorry. Actually, I could just put it down here. Okay, how are we going to get 10? Different ways of getting 10. One is I could add. And I would get how much? 80? Okay, adding is one method. What's another method? Yeah, multiply 8 times 10. Now, a shortcut is if you have 1. Does anyone see a shortcut? We know that multiplying by 10, could we say add a 0? So the point of this one is multiple methods. Thinking of not the way we think of it in algebra, where you're looking for a linear equation, but kind of if we're using proportional reasoning to look for multiple methods. Okay, I know you guys might be thinking this is painful. How about 5? How many sticks of gum in 5 packs? That's okay. That's okay. You know what? As we practice these, you're going to start to get a little better. We could add, right? How many sticks of gum would that be? $40? Okay. We could add. So this is add. We could multiply 8 times 5 equals 40. Now, does anyone see another interesting method, shortcut? Does anyone see a way to use divide? If I know 10 is 80, then 5 would be 40. So see how I can take 10 packs and divide it by 2? Okay, we are out of time, so we're going to go quickly. If 10 packs are 80, how much are 20 packs going to be? There we go. I'm going to double it and get 160. See how we're like creating pathways and dendrites by looking at it all these crazy ways? Okay. How about 100? What would be the easiest? Which one should I look at? Okay, having trouble here. Which one should I look at to get 100? Okay, I could just multiply by 8, or I could add a 0 to the 10. For 15, I could add the 10 and the 5 together. And for 125, I could add 105 and 20. How much is that? 800, 160, 40, and 1000. Okay, we're done. Or you can just multiply by 8. But this is what we're going to be doing. We're going to be trying to think of things with multiple pathways. All right. Sorry, I went three minutes over. We are done unless you have questions. If there's anything that I skipped, you can request it. We will do it together. Otherwise, you're going to do those on your own, and we are done. So you are welcome. Thank you, you too. Thank you for coming and sticking with it. I know it was kind of a lot of material. All right. Any questions? Or are we good? All right. Have a good day. Thank you.